Good day, everyone. My name is Joharto M. Tamontok from Bachelor of Science in Agricultural System Engineering. Welcome back to Fluid Mechanics, Chapter 5. So, our problem came from the book Lasagna, and I choose the problem 5-14. So the problem is, water flows at the rate of 8 meter per second through 80 mm diameter pipe and leaps through 50 mm diameter and 70 diameter pipes at the rate of 3 meter per second and 4 meter per second, respectively shown in the figure. Air at the top of the tank is escaped through 50 mm vent. Calculate the change of height and velocity of airflow through vent. Assume the fluid is incompressible. So here we know that what's going inside in the Q1 here in the pipe 1 is equal to what is going outside from the Q2, Q3, and Q4. So we will use the formula Q in is equals to Q out. So here, since we know that Q in is equal to Q1, we will use the formula of area 1 times the velocity 1 is equals to area 2 velocity 2 plus the area 3 times velocity 3 plus the area 4 times the velocity 4. So here in the figure we know that the velocity 4 is not yet given, and we are asked to find the height. So now what we're going to do is to first find the change of height. So the velocity 4 is also equals to the change of the height. So we will replace velocity 4 as change of height, or dH over dt. So now we have the formula area 1 times velocity 1 is equals to area 2 times velocity 2 plus area 3 times velocity 3 plus area 4 and the change of height, or dH dt. So now going back, we have the area 1 here is the area 1. So to calculate this area 1, we have the diameter of 80 mm. So we will convert it into meters. So that will equal to 0.08 meter. So we have also here the 8 meter per second. So to calculate the area of this pipe, we will use the formula of the formula for area of the cylinder is equals to pi over 4 times the diameter squared. So now we will input that formula here in the given. So here we know that the area 1 is equals to 0.08 meter per second squared, and times the velocity of the pipe 1, 8 meter, is equals to the area 2, which is the 2.05 meter, then squared, times the velocity of the pipe 2, which is 3 meter per second, plus the area of the pipe 3, which is we have a 0.07 meter diameter, and the velocity, which is 4 meter per second, plus the area 4. So in the figure we have 50 mm, so that will equal to 0.05 meter, and velocity is still unknown, but we have the dH dt. So now if you put it here in calculator, we will get the answer of 9.64 meter per second. So now we have the height. So now we will look for the velocity 4. So to find that, we know that Q4 is also equals to dQ air. So next is we will use the formula of that. So this one is the area from the pipe 4. 0.05 is the diameter of the pipe 4, and the velocity is still unknown, so we will find it. and this 0.06 is the diameter of the tank, and this one is the height. So now if you put this in calculator, we will get the answer of the velocity 4 is equal to 1388.16 meter per second. So that is it on how this is solved. Thank you for watching.